hope you enjoyed that spherical mirror video. I know I did. In this video, I'm going to talk about introducing the concept of a mirror that is curved. And before I do that, I want to make sure that we understand the difference between diffuse and specular reflection. So remember that diffuse reflection is off of a really bumpy, rough surface, and then an angle or that an incident ray coming in here is going to get reflected at some other angle that is probably not going to be the angle that you would expect off of a smooth surface like a mirror. And the reason for this, I said before, is because the surface of reflection is going to be different for this entire curve right here. This entire curve. They're all going to have kind of a different feel as what the surface is going to be. At this point right here, the surface is going to look something like this. It's going to look something like this. So the normal line is going to be perpendicular to the surface. So if I wanted to do this whole angle of incidence, angle of reflection thing, I would have to keep that in mind as I was making my reflected ray. So another ray, let's say it's coming in at this point right here. At this point right here. And you have to understand that the surface of reflection is doing something like this. And this is perpendicular. So if it's coming in at this angle, it's going to go out at that angle. Okay, so as you can see, this is different than specular reflection, because if I had the same two rays, they would do some predictable things, like you would expect it to reflect like that. And they actually reflect at unpredictable angles because this surface of reflection, also known as the tangent line, is going to produce a different normal. So we'll make a note of that right here. So the surface of reflection, aka the tangent line, aka the tangent line, is going to be producing a normal line that's perpendicular that's going to give you a different angle of reflection. Now, this plays into our little discussion of what a curved mirror is going to do. And essentially, we're going to take a look at what could happen. So let's say I have a mirror right here, and the name of this, we're assuming that we're taking some sort of a spherical object and we're actually kind of cutting it a little bit. Like we're taking the surface of this sphere and we are putting some sort of reflective surface, either on the inside or the outside. I'll get into the difference. One of them is called concave. The other one is called convex. And the difference between these isn't really important. We're just going to call it spherical. We're going to call it spherical for now. You'll also see the word parabolic, and these terms are not synonymous, but they are similar. You'll also see parabolic, but we're going to talk about a sphere and how we kind of sectioned off a piece of the sphere. So let's say that we have part of a sphere, and we're trying to determine what would happen if I introduce some rays of light. So the first thing that we need to do is create some sort of a center, and the center is going to go through the vertex of this section of the sphere. So remember in algebra class, if you have a parabola right here, or a parabola facing downward, this is the vertex, this is the vertex. It's either the highest or lowest point on a parabola. Why I'm making this dotted line going through the minimum or the lowest point on this section of the sphere. And you'll see why in a second. So let's say that I have a ray of light that's going to come in like this. Okay, like this. Well, remember, this surface is most certainly not smooth in the fact that the surface of reflection is identical all around. It's not straight up and down, where if I produce a angle of incidence here, you know the angle is just going to get reflected back, and it's going to trace back somewhere over there. So what's going to happen is I have to draw the tangent line, or the surface of reflection, at this point. Remember, we did an activity where you kind of moved it around, moved the cursor around, or I moved it around, and we kind of saw what the tangent line would be. So it's going to somehow kind of look like this. Surface of reflection is going to kind of look like that. So perpendicular to the surface of reflection is going to be the normal line. So I'll go and label that as the normal line, N, or I guess I'll just write out normal. Okay, so the angle of incidence is created by this incident ray forming an angle with the normal line. Now the angle of reflection is going to be the exact same as the angle of incidence. So my ray, do it in a different color, my ray is going to look something like this. It's going to look something like this. So just to reiterate really quickly, this incident ray is coming in, the surface of reflection is actually kind of tilted. Okay, this is also called the tangent line. But the surface of reflection is a little tilted, it's a little weird, but from this we can draw this normal line. And we need this normal line in order to create this angle of incidence. This angle of incidence is equal to this angle of reflection, and we've created our first ray. Now I'm going to draw another ray. I'm going to draw another ray, and maybe we'll make it come over here. Maybe we'll make it come over here. And if we make this incident ray come over here, the surface of reflection at this point is going to look something like this. It's going to look something like that. So drawing the tangent line is going to be perpendicular to this line right here. And we're going to draw it right about here. That kind of forms a 90-degree angle. Okay, so this incident ray is coming in with respect to this normal line. So this is the normal line, and this is what we're going to use to create this angle right here. This is the angle of incidence. The angle of reflection is going to be the exact same, and it's going to do something like this. Okay, so these two angles should be identical, and you can see a pattern. You can see kind of a pattern. And I'll do it with one more ray because I know it's kind of getting a little crowded. Let's say I go all the way down here. The surface is going to look something like this. It's going to look something like this. Which means my normal line is going to be perpendicular like that. That's my normal. And then we've just created our angle of incidence, and we are going to make that equal to the angle of reflection. And if you notice that all of these rays are parallel, all of these rays that I've drawn right here are never ever going to touch if they keep going. If this mirror were not there, these rays of light would keep on going forever without intersecting. Now, what do you notice about what's happened here? Well, all of these, assuming they're parallel, which light is going to be pretty much parallel from something like the sun, it's going to produce light rays that are all going to be parallel in these directions. And essentially, they are all intersecting at a point right here. And the point they're intersecting at, it just so happens to be touching the line that I drew through the vertex right here. And this point right here has a special name. Oh, that's not the color I wanted. This has a special name called the focus. It's called the focus. I'm going to refer to that a lot in our discussion of spherical and or parabolic mirrors. So that is the focus. That is the focus. I want to introduce you to another idea as well, and we have the same kind of idea, a spherical mirror. We can actually draw an image just like we did with a plane mirror. So this is a plane mirror, and if we had an image like this, it would be reflected, and this would be our image. And it is virtual, because it is behind the surface of reflection. If I have a person standing right here, he's going to be able to see this in the mirror, but if he goes behind the mirror in the adjacent room or whatever, that image does not exist. Like there's nothing there. But we're going to see something different with this real image that I'm about to create. Same situation applies. I'm just going to draw a ray, and this is considered a ray diagram. So the first thing I'm going to talk about is we're going to assume that at every single point along this object, light is going to reflect diffusely, meaning it's going to scatter in a bunch of unpredictable directions. But I'm actually going to just simplify this, and I'm going to show you 2 directions this light could possibly go in. That's going to be enough to create our image. So the first one is one that we've already worked with. It's just going to be straight on, parallel to the surface. So we're going to make this incoming ray go right here. And then we have to create the surface of reflection like this. That's pretty bad. That's pretty bad. But you can hopefully get the idea. So that is my perpendicular, or my normal. Then angle of incidence equals angle of reflection. It's going to look something like that. Something like that. It's going to keep doing that. Well, this is going to end up being our focus. This is going to end up being our focus. So I want to indicate that somehow. I'm just going to highlight it, and we're just going to assume that it's called the focus. So this portion right here is called the focus, where all the light's going to be concentrated at, and I showed you that in the previous diagram. Well, you can kind of treat this like an if-then statement. If my light is going toward the mirror in a parallel way, so straight on, then it's going to go through the focus. It's going to go through the focus. Well, the converse of that is also going to kind of be true in this case. And I'll explain why in maybe a future video or in a future lecture, but just trust me on this. If we decide to change the angle and instead go through the focus, we are going to get a parallel reflected ray. We're going to take a look at that right now. So let's say this second reflection is going to go straight through the focus. And again, I could have picked any direction to go in, but I picked straight on, so parallel, and then through the focus. Okay, well, I'm going to draw my surface again. I'm going to draw this perpendicular. I'm also going to draw this. Well, this is going to end up going forever and ever and ever in this direction because it's a ray, and that's what rays do. And this ray is going to go forever and ever and ever until they meet up at this point right here. Now remember, that is the tip of our arrow. I can do this for any number of points, and I'm not going to show that in this ray diagram because it would get really complicated. But the idea is, from this poor diagram, the idea is we are essentially creating an image that's going to look like this. So this is our actual object, the one in black. That's our object. And our image, you'll notice, is inverted, and you can look at some characteristics later, but you'll notice that it is in front of our mirror. That is the most important distinction that you need to make right now. This image is actually in front of the mirror. Well, that makes it a real image. That makes it a real image because I could put like a tablecloth or a sheet of paper right here, and the image would actually show up on that blank canvas. So this is a real image. Okay, and in future lectures and videos, I will go more into depth on how all of this works, but I just wanted to give you a brief introduction on what a real image is, how that contrasted with a virtual image, and some intro to how to look at ray diagrams involving curved mirrors. Anyway, I hope that was very helpful, and thanks for watching.